Hi, today we will see the different kinds of ignition systems from basic mechanical engineering. The ignition system, the spark ignition engines, requires some device to ignite the compressed air fuel mixture inside the cylinder. At the end of the compression stroke, the ignition systems serve this purpose. It is a part of the electrical systems which carries the electrical current to spark plug, which gives a spark to ignite the air fuel mixture at the correct time. The ignition systems consist of battery, switch, ignition distributor, ignition coil, spark plugs, and necessary wiring. Some systems use transistors to reduce the load on the distributor contact points. Other systems use a combination of transistors and magnetic pickup in the distributor. The compression systems engines do not have such ignition systems. In a compression ignition engines, only the air is compressed in the cylinder. At the end of the compression stroke, the fuel is injected, which catch the fire due to the high temperature and pressure of the compressed air. Requirement of an ignition systems. The ignition systems supplies high voltage surges of current to the spark plug. These surges produce the electric sparks at the spark plug gap that ignite or set the fire compressed air fuel mixtures in the combustion chamber. The sparkling must be take place at correct time at the end of the throttle operations. The spark is advanced so that it occurs somewhat earlier in the cycle. The mixture thus has sufficient time to burn and deliver its to power. The ignition system should be function efficiently at the maximum and minimum speeds of engines. It should be easy to maintain, the light and compact. It should not be cause any interference. Types of an engine: battery ignition systems and magneto ignition system. The battery ignition, both ignition systems are based on the principles of mutual electromagnetic induction. Battery ignition system is mostly used in the passengers and light trucks. In the battery ignition systems, the current is primary winding is supplied by the battery, whereas the magneto ignition system, magneto produces the supplies the current to the primary winding. Battery ignition systems for a 4-cylinder engine, it consists of battery, ammeter switch, ignition coil, condenser, contact breaker, distributor, spark plug, primary ignition circuit, start and battery, and passes through the switch, ammeter, primary winding. Contact breaker points to the ground. A condenser is also connected in a parallel to the both breaker point. One end of the condenser is connected to the contact breaker arm and other end is grounded. The secondary ignition circuit is not connected electrically to the primary ignition circuit. It starts the ground and passes through the secondary windings, distributors, spark plug to the ground. The ignition coil setups 6 or 12 volts of the battery, the retention voltage is 20,000 to 30,000 volts required to jump at the spark and the spark plug gap, which ignites the compressible charge in the cylinder. The rotor of the distributor revolves and distributes the current through segments, which in turn send it spark plugs. The purpose of the condenser is to reduce the acting of breaking points and thereby prolong their life. Because the ignition system is the 4-cylinder engine, the cam of the contact breaker has the 4 loops. It makes the brakes and contact the primary circuit 4 times in every revolution of the cam. When the ignition switch is on, the current will flow through the battery, the primary winding. It produces the magnetic field in the coil. When the magnetic field induces the current in the secondary winding coil. Because the secondary winding has many more turns of the wire, the voltage increases up to 30,000. The primary winding consists of 200 to 300 grams of the thick wire. 15,000 volts are necessary to make the spark jumps at 1 mm gap. The distributor then directs the voltage proper spark plug when it jumps the gap, producing the spark, ignite and combustible mixture in the cylinder. Magneto-ignition systems. The magneto-ignition system of 4-cylinder engine, it consists of magneto instead of battery, which produces the supplies current in the primary winding. Remaining arrangement in this system same as the battery ignition systems. The magneto consists of fixed armature having a primary and secondary winding and rotating the magnetic assembly, which is driven by the engine. When the magnet rotates and current flows through the primary winding, the secondary winding gives the high voltage current and to the distributor, which distributes it to the respective spark plugs in magneto and magnetic field is produced by means of the permanent magnet. Whereas the conventional generator, the magnetic field is produced by passing some generated current through the field winding, which produces the magnetic field. The magneto may be either rotating armature type or rotating magnetic type. In the armature type magneto, the armature carrying the primary and secondary windings and the condenser between the poles of the stationary horseshoe magnet. Battery ignition systems. Current is obtained from the battery. Sparking is good at low speed. Starting of engine is easier if the battery is discharged. The engine cannot be started, occupies the more space, complicated in wiring, less cost, spark intensity of the engine and the speed is rises, used in car, buses and trucks. Current is generated by the magneto, poor sparking at low speed, difficult to starting, no such difficulty as battery is not needed, occupies the less space, simple wiring, more cost, spark intensity improves and the engine speed rises. Used in motorcycles, scooters, and racing cars. Spark plug. Spark plug is a device to produce the electric spark to ignite the compressed air fuel mixture inside the cylinder. Spark plug is screwed in the top of the cylinder so that the electrodes projects in combustion chambers. The function of spark plug is to ignite the compressed air fuel mixtures inside the cylinder. It must be produce the spark at the correct moment at the end of the compression stroke. Proper gap is maintained between the two electrodes of the spark plug so that the sparking may take place. When the spark plug is screwed in the cylinder head, the ground electrode is said to be connected with ground. The terminal of the center electrode is directly connected with HT lead of ignition coil in the case of single cylinder engine, through the distributor in the case of multi-cylinder engine. The secondary circuit of electrical system is completed through the gap between the electrodes. When the HT current passes through the circuit, it jumps the gap, producing a spark which ignites the compressed air fuel mixture in the cylinder. The ignition systems of diesel engine. Diesel engines are generally called compression ignition engine. In diesel engine, pressure is drawn into the engine cylinder during the suction stroke. The air is compressed to the high compression ratio of the order of 12 to 18 during the compression stroke. The air pressure at the end of the compression is about 3500 kilonewton per meter square. The temperature at the end of the compression is about 600 degrees centigrade. The fuel is injected into the engine cylinder in the form of the fine spray at the end of the compression stroke. The temperature of the air higher than that of the self-ignition temperature of the fuel injected, and hence the fuel air mixture is ignited simultaneously. Engine cooling. During the combustion of air fuel mixtures, enormous amount of heat is produced inside the engine cylinder, and the temperature at high 2500 degrees centigrade may be reached by burning gases. The temperature is too high, it will break the lubricating flame between the moving parts. Moving parts may be cause any mechanical breakage of engine parts. Hence, the temperature must be reduced by some means of to such value about 200 degrees centigrade to 250 degrees centigrade, at which the engine may be worked efficiently. Too much of cooling would, however, the lower thermal efficiency of the engine. Thus, the purpose of cooling system is to keep at its most efficient operating temperature at all engine speeds and all driving conditions about 15%, the total heat is produced is utilized for usual work at the crankshaft. The remaining amount of the heat absorbed in the frictions removed by exhaust gases and taken by cooling system. The cooling system is designed to remove about 30 to 35% of heat produced by the engine cylinder. When the combustion takes place, the cylinder walls, cylinder head, piston and piston walls heated. There the temperature should not be reach excessive values. They must be cooled by some means of desirable temperature. It is also noted that the engine is quite insufficient when cooled. The cooling system is so designed that it prevents cooling until the engine reaches to its normal operating temperature. When the engine warms up, the cooling system begins to function. It cools rapidly when the engine is too hot, and it cools slowly, not at all when the engine is cool is warming up. The most of the engine are designed to operate the definite temperature range, which will ensure the correct clearance between the parts. The promote the vaporization of the fuel, keep the oil the best viscosity to prevent condensation of the harmful vapor. Methods of cooling. 4 methods of cooling are air cooling, water cooling, and liquid cooling, and cooling fins. In this method, air cooling, heat is distributed directly to the air after being conducted through the cylinder wall. Fins and the flanges on the outer surfaces of the heads serves to increase the area exposed to the cooling air and so raise the rate of cooling. The basic principles involved in these methods have current of air flowing continuously by heating the surface of the engine, and the heat is removed. Amount of the heat dissipated depends upon the following factors: surface area of the metal contact with air, rate of airflow, the temperature difference between heated surface and air, conductivity of the metal. For effective air cooling, the surface area of the metal which comes in contact with the air increased by providing the fins over the cylindrical barrel, and more than the surface area in contact with air, more heat is dissipated. The high rate of air flow and higher heat dissipated. Similarly, the higher temperature difference between the heated surface and air, the higher will be heat distribution. A metal having the higher conductivity dissipates the more amount of heat. The advantages of AC cooled engine: the lighter in weight due to the absence of radiator, no topping up the cooling systems, no leakages to guard against, antifreeze is not required. The engine warm up faster than the water cooled designs, can be operated in cold climates. The water may be freeze, can be used in areas where there is a scarcity of cooling water. Disadvantages of the air-cooled engine: less sufficient cooling, not easy to maintain even cooling all around the cylinder, more noisy operations, limited use of the motorcycles, scooters and cylinders exposed in the airstream. Cooling fins: the surface area over the cylinder is increased by means of fins. These fins are either cast as an integral part of the cylinder and separate finned barrels are inserted over the cylinder barrel. Sometimes, particularly in aero engines, how the fins are machined from the forged cylinder blanks. As a rule, the fins are usually made about the cylinder wall thickness at their roots, tapering down to about one half of the root thickness. The length of the fins varies from 1/4 to the 1/3 of the cylinder diameter. The distance between the two fin center is about 1/4 and 1/3 of the length. The water cooling: in this method, the water is circulated to the water jacket around each combustion chamber. The cylinders, valves, seats and volume systems. The circulating water, when passes through the engine jackets in block and cylinder, heat take place of the heat of the combustion. When it passes through the radiator, it is cooled by air drawn through the radiator by a fan and by airflow developed by the forward motion of the vehicle. After passing through the radiator, the water again goes to the engine jackets. The system of water coolings or thermospion system and force regulation systems. Thermopion systems: in these systems, the water cooling system of water cooling circulation of water is obtained due to the different destinies of hot and cold regions of cooling water. There is no pump to circulate the water in the hot water from the engine jacket is being lighter and raises up the hose pipe and goes the radiation from the top side. The cooling and the ends goes down down at the bottom side of the radiator. When it goes again the engine jacket, the system is quite simple and cheap, but the cooling rather than slow to maintain the continuity of the water flow. The forced circulation in the systems: water pump is provided to force the water into the water jacket of the cylinders. The water pump forces the cold water from the radiator and the jackets of engine cylinders, so the engine gets cooled, the water gets heated, some of the dents of the ends rises up, the enters into the radiator and through the thermostat. The hot water is cooled by the radiator fins and the fans are provided the engines. While traveling down in the radiator, the cold water is circulated by the water pump. Again the water cooling the engine parts. The advantages of forced circulation system: the efficient cooling and uniform cooling applicable for both light duty and heavy duty engines, and engine temperatures can be controlled. Disadvantage: requires more space, heavy weight, maintenance cost is more, chance to corrosion of the formations during the cold conditions. The water may be get frozen. The lubrication is essentially required for the more vehicle maintenance to supply the lubricating oil, and the moving parts is simply termed as the lubrication. The lubrication of all moving parts is pre-lubricated is essential to reduce the friction, wear, and prevent seizure. The lubrication must be done properly, and right type of lubrication should be used. Improper or inadequate lubrication of engine will cause a serious trouble such as stored cylinder, burnout and worn and burnout, the bearing of the excessive fuel consumptions. Object of lubrications to reduce the friction of moving parts, reduce the wear of moving parts, to act as a cooling medium for removing heat, to keep engine parts clean, especially piston rings and grooves, to absorb the shocks between the bearings and other engine, this reducing the engine noises and extending the engine life, to form the good seal between the piston rings and cylinder walls, to prevent the depositions of the carbon, salt of lacquer, to carry away harmful substances resulting from the incomplete combustions, to prevent metallic component from the corrosive attack by the acid from formed during the combustion process, to assist the oxidation which causes the sludge and lacquers. Lubricating systems, petroleum systems, splash systems, and process systems. Petroleum systems. These systems lubrication is generally adopted in two-stroke petrol engines like scooter, motorcycle. It is the simplest form of the lubricating systems. It does not consist of any separate part like oil pump for the purpose of lubrication, but the lubricating oil is mixed into the petrol itself while filling the petrol tank of the vehicle is in the specified ratio. When the fuel goes into the crankshaft during the engine operations, the oil particles go deep into the bearing surfaces and lubricate them. The piston rings, cylinder walls, piston pins, etc. are lubricated in the same way. Splash systems. In this system of lubrication, the lubrication oil is stored in an oil through sump. The scoop of the dipper is made in the lowest part of the connecting rod. When the engine runs, the dipper dips in the oil, and once the every revolution of the crankshaft of the cause the oil and splash the cylinder wall. This action affects the lubrication of engine walls, piston ring, crankshaft, bearings, and big end bearings. The splash system is mostly used with the pressure systems in an engines. Some parts are lubricated splash systems and other type of by the process systems. The process systems, in these systems, the engine parts are under the lubricator under the pressure of the feed. The lubricating oil is stored in separate tank or sump. From the oil, the pump takes place the oil to the strainer and delivers through the filter. The main oil gallery pressure is 2.4 kg per centimeter square. The oil from main gallery goes to main bearings, from where some of its lubricating main bearing fails to back some is splashed to lubricate cylinder walls, and remaining goes through the holes of crank pin. From the crank pin it goes the pistons to pin through the hole connecting rod web. When it lubricates the piston rings for lubricating the camshaft and timing gears, oil is led through the separate in oil line from the oil gallery. The valve tappets lubricated by connecting the main oil gallery to the tappet guide the surfaces through the drilled hole. An oil pressure gauge at the instrument the panel indicates in the oil pressure in the systems. Oil filters and strainers in the systems clear off an oil from the dust, metal particles and other harmful particles. Other type of engines, hybrid engines vehicles. The hybrid engine vehicles uses the two or more distinct power sources to move the vehicles of teams. Most commonly refers the hybrid vehicles which combine the internal combustion engines and one more electric motors engine with some hydrogen as a fuel. The hydrogen vehicle is a vehicle that uses hydrogen acids on board the fuel for motive power. The term may refer to personal transportation of vehicles such as automobile or any vehicles that uses the hydrogen in a similar fashion, such as an aircraft. Power plants of such vehicles converts the chemical energy of hydrogen of mechanical energy in one of the two methods: combustion, electromechanical conversions in the fuel cells. In hydrogen internal combustion engine vehicles, hydrogen is combusted in the engines, fundamentally the same method as the traditional internal combustion engine vehicles. Biodiesel engines. Biodiesel engines refer the vegetable oil, animal fat based diesel fuel consists of the long chain algae. The biodiesel is typically made of chemically reacting lipids with an alcohol. The biodiesel is meant to be used for the standard diesel engine, is thus distinct from the vegetable based oil used to the fuel converted to the diesel engines. Biodiesel can be used alone and blended with diesels. The boilers. The boilers is an apparatus to produce the steam. The thermal energy is released by the combustion of fuel, transferred to the water, which vaporizes and gets converted into the steam at the desired temperature and pressure. The steam is used for producing the mechanical work by expanding heat in steam engine, the steam turbine, the heating at the residential and industrial building, performing the certain process in the sugar mills, chemical, textile industries. The boiler is closed vessel which the water is converted into the steam by application of heat. The safety of boiler should be safe under operating condition. Accessibility. The various parts of the boiler should be accessible for repair and maintenance. Capacity. The boiler should be capable of supplying the steam according to the requirements. Efficiency. permit the efficient operations of the boiler should be able to absorb the amount of the heat produced due to the burning of fuel in the furnace. It should be simple and construction, and its maintenance cost should low. Its initial cost should be low. The boiler should have no joints exposed to the flames. The boiler should be capable of quick starting and loading. The performance of boiler may be measured in terms of evaporative capacity, also called as the power of boiler. It is defined as the amount of the water is evaporated or steam produced per hour. It may be expressed in kg per fuel burnt. The, the classification of boiler. Based on its position, horizontal, vertical, inclined. The fire tube boiler and water tube boiler, based on the place of firing. The externally fired boiler, internally fired boiler, based on circulation, forced circulation, and natural circulation, based on the pressure, high pressure boiler, low pressure boiler, based on the mobility, stationary boiler, portable boiler, based on the number of the tubes, single tube boiler and multi-tube boiler. If the axis of the boiler is horizontal, the boiler is called horizontal boiler. If the axis is vertical, the boiler is called vertical boiler. If the axis is inclined, the boiler is known as inclined boiler. The parts of the horizontal boiler can be inspected and repaired easily. It occupies the more space. Vertical boiler occupies the less floor area. In the fire tube boilers, all gases are inside the tubes and the water surrounds the tubes. The coherent and locomotive boilers, water tube boilers, inside the tube, the gases are surround them. Babcock and Wilcox and Yarrow boilers. The boilers is known externally fired boiler outside the shell. The Babcock and Wilcox boiler, Stirling boilers. In the case of the internally fired boilers, the furnace is located inside the boiler shell. The examples are Cochrane and Lancashire boiler. Forced circulation boiler. The circulation of the water is done by the forced pump. Velux Normand Benson boiler. The natural circulations. Types of boiler. The circulation of water in the boiler takes place due to the natural convection currents produced by the application of heat. Example, Lancashire and Babcock and Wilcox boiler, etc. The boiler is which produces steam at the pressure of the 80 bar and above are called the high pressure boilers. The examples of Babcock and Wilcox and Velox, Lamont and Benson boiler. The boiler which produces the steam at the pressure below the 80 bar are called low pressure boiler. The Cochrane and Cornish, Lancashire and locomotive boiler. Primarily the boilers are classified as either stationary or mobile, and the stationary boilers are used for power plant steam, for the central stations, utility power plants, power plant process, steam, etc. The mobile boiler or portable boilers include the locomotive type and other small units for temporary use at sites. The fire tube boilers are classified the single tube and multi tube boilers depending upon whether the fire tube is the one or more than one. The examples of the single type by Cornish of the simple vertical boiler and rest of the boiler is a multi-tube boilers. The selecting of boiler, the working pressure of quality of steam required, the steam generation rate, floor area available, accessibility of inspection, comparative, the initial cost. The erection facilities, the portable load factors, the fuel water is available, operating and maintenance costs, the application of boiler, the steam generated by the boilers are used for following purposes. Steam is used to drive the moves such as steam turbine, the steam engines and prime movers in turn drive the electric generator to produce the electricity. The steam is used in industries, textile, chemical, sugar, paper, leather, breweries, etc. The industry processing such as sizing, bleaching, etc. The steam is used in winter air conditioning of industrial, residential and industrial building is also used for producing the hot water boiler terms shell. The shell is a boiler consists of more steel plates bent to the cylindrical form and riveted welded together. The shell ends are closed with end plates. The shell setting, the primary functions of setting is to confine the heat to the boiler and form the passages of for passages of gases, and it is made of brickwork and may form the wall and the furnace and the combustion chamber. It is also provide the support in some types of boiler. The grate, it is the platform of the furnace which the fuel is burnt. It is made of the cast iron bars. The bars are so arranged that the air may be passed on to the fuel for combustions. The area of grate on which the fire rests on in a cool wood fired boiler is called the grate surface. The furnace, it is a chamber formed on the space above the grate and below the boiler shell in which the combustion takes place. It is also called as the firebox. Water space and the steam space, the volume of the shell that is occupied by the water is termed as the water space, while the entire shell of the less water and tube space is called the steam space. Accessories, the items of superheater, economizers, feed pump, etc. are termed as accessories. The form of the integral part of the boiler. This increases the efficiency of the boiler. Water level, the level of the water stands the boiler is called the water level. The space above the water level is called the steam space. Foaming, the formation of bubbles of the water due to the high surface tension of the water. The scale is deposit medium due to the extreme hardness curing and the water heating surfaces of the boiler because the desirable condition of the boiler water in blowing off the removal of mud and other impurities of the water from the lowest part of the boiler. Blowing off accomplished blow clock and blow clock or valve lagging the blocks asbestos magnesia installations wrapped outside of the boiler shell or stream piping the refractory and the heat insulation of the material such as the fired brick and the plastic fire clay used for adding the combustion chamber. Simple vertical boiler. It is the fire tube boiler. It consists of cylindrical shell, greater portion is full of water and remaining is the steam space. At the bottom of the firebox, grate on the fuel burnt and ash from the falls in the ash pit. The firebox is provided with two cross tubes, increases the heating surface and circulation of water. The cross tubes are inclined to each other, ensures the efficient circulation of water. At the ends of the each cross tubes are provided by the hand to give the access for cleaning these tubes. The combustion of gases after heating the water and thus converting it to the steam escapes to the atmosphere through the chimney. Manhole is provided to clean the interior of the boiler or exterior combustion chamber and chimney. The various mounting of pressure gauge, water level indicator, safety valve, steam stop valve, feed check valves, water level gauge, the flow combustion gases, the circulation of water in the water jackets are indicated. The rate of the productions such as the boiler normally does not 2500 kg per hour. The pressure is normally 7.5 to 10 bar. A simple vertical boiler is self-contained and transported easily. The coherent boiler. The boiler consists of a cylindrical shell with the crown having the spherical shape. The furnace is also hemispherical shape. The grate is also placed at the bottom of the ash pit and is located below the grate. The coal is fed into the grate through the fire or door and ash formed and collected. The ash pit located just below the gate and is removed manually. The furnace and the combustion chambers are connected through the pipe. The back of the combustion chamber is lined with fire bricks. The hot gases from the combustion chamber flow through the nest of horizontal fire tubes, then passing through the fire tubes transfer the large portions of heat of the water by convection. The flue gases come out of the fire tubes or finally discharged to the atmosphere through the chimney. The spherical top of the spherical shape of the firebox or spherical special features of the boiler. These shapes requires least material for the volume. Hemispherical crown of the boiler shell gives the maximum strength to withstand the pressure of the steam inside the boiler. The hemispherical crown of the firebox is advantageous for resisting the intense heat. This shape is also advantageous absorption of the radiant heat in the form of the furnace. The coal or oil can be used as a fuel boiler. If the oil is as a fuel, no grate is provided by the but the bottom furnace is lined with fire bricks. Oil burns and the burners are fitted for the suitable locations below the fire door. The manhole near the top of the crown of the shell is provided for cleaning. In addition to this, the number of the handholds are provided around the outer shell. Cleaning purpose, the smoke box is provided with doors and for cleaning the interior of the fire tubes. Airflow through the grate is caused by means of the draught produced by chimney. The damper is placed inside the chimney to control the discharge the hot gases from the chimney and thereby the supply of air. The grate is controlled. The chimney may be also provided the steam nozzle. The steam to the nozzle is supplied from the boiler. The outstanding features of these boilers are it is a very compact and requires the minimum floor area. Any type of the fuel can be used with this boiler. It is well suited for the small capacity requirements. It gives a 70% thermal efficiency, about 75% of oil firing. The ratio of the grate area is to heating surface area varies from 10 is to 1, 25 is to 1. It is provided with all record all mountings. The functions of the boiler mountings is the pressure gauge. This indicates the pressure of the stream in the boiler. The water level indicator, this indicates water level in the boiler. The water level in the boiler should not be fall below the particular level, otherwise the boiler will be overheated and the tubes may be burned out. Safety valve, the functions of safety valve is to prevent increase of steam pressure in the boiler above the design pressure. When the pressure increases above the design pressure, the valve open and discharge the steams to the atmospheric pressure. The fusible plug in the water level in the boiler falls below the predetermined level. The boiler shell tubes will be overheated. If it is continued, the tubes may be burned. As the water will removed, it can be prevented by stopping burning of fuel grid. When the temperature of the cell increases above the particular level, the fusible flux melt and forms an opening. Blow-off cock, the water is supplied to the boiler always contains the impurities like mud, sand and salt due to the heating of these deposited at the bottom of the boiler, and if they are not removed they are accumulated at the bottom of the boiler and reduces the capacity. The heat transfer rates also salt content goes on increasing due to the evaporation of water. These deposited salts are removed with the help of the blow-off cock. The cock is located at the bottom of the boiler. The operated only the boiler is running. The blow-off cock is opened during the running of the boiler. High pressure of the steam pushes the water and collected the material and the bottom blown out. Blowing some water also reduces the concentration of salt. This keeps the boiler clean. Steam stop valve. The valve flow the steam of supply outside. The steam from the boiler first enters into the anti-priming pipe where the most of the water particles is associated with the steam is or removed. Feed check valve. The high pressure of the water is supplied to the boiler through this valve. This valve opens towards the boiler only and feeds the water to the boiler. The feed water pressure is less than the boiler steam pressure. Then this valve remains closed, prevents the back of the stream of the through the valve. Lancashire boiler. It is a stationary fire boiler, internally fired, horizontal lateral circulation of the boiler. This is widely used boiler, good steaming quality and ability of the quality, interior quality. This boiler have the cylindrical ability of 2 meter diameter and its length is 8 meter to 10 meter. It has two large internal flow tubes having the diameter 80 centimeter to 100 centimeters in which the grate is situated. The boiler is set the brickwork forming the external flow so that the external part of the shell forms the part of the heating surface. The boiler consists of cylindrical shells and two big furnace tubes passes through the right through this. The brick sheeting forms the one bottom flue and two side flues. Both the flue tubes which carry the hot gases leave below the water level. The grates are provided at the front end of the main flow tubes of the boiler and the coal is fed the grates. The fire doors low bridge is provided at the end of the grate to prevent flow the coal ash particles into the interior of the fire furnace tube. The otherwise the ash coal particles is carried with the gases from the deposits on the interior of tubes and prevent the heat transfer to the water. Frederick Bridge and also helps deflecting the hot gases upward to provide the better and heat transfer. The hot gases leaving the grate passes up to back end of the tubes and then the downward directions they move through the bottom flue on the front of the boiler where they are divided into the two and passes side flues. Then they move along the two sides of the flue, come to chimney. With the help of this arrangement of flow passages of gases, the bottom of the shell the first heated and then its sides. The heat is transferred to the water through the surfaces of the flow tubes and the bottom parts and side of main shell. The arrangement increases the heating surface to a large extent. The dampers of form sliding doors are placed at the end of the side flues to control the flow of gases. This regulates the combustion rate as well as the steam generation rate. These dampers are operated by chain passings over the pulley by the front of the boiler. This boiler filled with usual mountings. The pressure gauges of water level indicators are provided at the front, whereas the steam stop valves is safety valve, low water, and the high steam safety valve is the manual are provided on the top of the shell and blow off cork situated beneath the front portion of the boiler shell for removal of sediments and mud. It is also used for the empty of the water in the boiler whenever required for the inspection. The fusible flex are mounted on the top of the main fuses just or over the grates to prevent overheating the boiler tubes, extinguishing the fire when the water level falls below the particular level. The water level alarm is mounted on the boiler, warning in the case of the water level going below the precast value. The feedback of the valve is a front end plate, the feed pipe projecting onto the boiler and perforated so that the water is uniformly distributed cells in this surface area per unit volume. The boiler is considerably large. The maintenance is easy. It is suitable for large reserve of the hot water is needed. The boiler is due to the large reserve capacity can easily meet the fluctuations. The water tube boilers are used extensively when the pressure above the 10 bar in excess 7000 kg of steam per hour is required. The Babcock and water box example, the horizontal straight tube boilers may be designed as a stationary of marine purposes. The diameter of the drum, the length, size of the water tubes, size of the superheated tubes, working pressure, the steam capacity and efficiency. The Babcock boiler with longitudinal drum, it consists of the drum connected to the series of the front end of the rear end of the headers by short racer tubes. Thank you. We'll see in next video.